NASA and CU Boulder launch rocket to study the Sun. Get ready for an exhilarating journey into the cosmos. On Friday, NASA, in collaboration with the University of Colorado Boulder, is set to launch a remarkable 60-foot rocket from New Mexico. This mission promises to reach supersonic speeds in mere seconds and will complete its scientific objectives in approximately 15 minutes. Scheduled for liftoff at 1 p.m. Mountain Daylight Time from the White Sands Missile Range, a military facility in New Mexico, this sounding rocket will carry out vital research on the Sun. Sounding rockets are designed to transport scientific instruments into space, allowing researchers to conduct experiments and gather data, typically returning to Earth within a short span of 15 to 20 minutes. These rockets are a more economical option compared to larger orbital rockets, which are generally used for extended space missions. The rocket launching this Friday will be equipped with a specialized instrument known as the SNIFS payload, or Solar Eruption Integral Field Spectrograph. This innovative device has been meticulously designed and constructed by a dedicated team of scientists, engineers, and students at CU Boulder's Laboratory for Atmospheric and Space Physics, LASP. The SNIFS is a cutting-edge ultraviolet spectrograph capable of capturing images of the Sun while simultaneously analyzing incoming light based on its wavelength. This dual functionality will enable researchers at LASP to observe various phenomena occurring on the Sun, such as fluctuations in temperature and movements of plasma. Vicky Hurd, a former doctoral student involved in the project who graduated from CU Boulder in December, expressed her enthusiasm. We can actually use this to inform ourselves of the 3D structure and movement we're looking at on the Sun. The entire mission is expected to last around 15 minutes. The rocket will ascend to an altitude of 150 miles above Earth in about a minute and a half, during which the SNIFS instrument will spend approximately 8 minutes collecting data and monitoring the Sun. After completing its mission, the rocket will descend back to Earth via parachute, landing in the New Mexico desert, where a helicopter will retrieve it. I'm so excited, Hurd shared. We've been working on this for so long, and I've been dreaming about getting to see our own launch. Phil Chamberlain, a senior research associate at LASP, has dedicated over 4 years to the development of the SNIFS instrument. This launch marks his debut as the principal investigator, or lead researcher, on a project. We've faced numerous challenges along the way. It's been a roller coaster ride, but we're ready, Chamberlain stated. I'm confident it will be successful. I feel a bit nervous, but also incredibly excited. One of the primary objectives of this mission is to enhance our understanding of the Sun. The LASP team will concentrate on investigating solar spicules, which are small eruptions occurring in the Sun's chromosphere. The chromosphere is a thin layer of plasma situated between the Sun's visible surface and its outer atmosphere, known as the corona. When spicules erupt, they heat up and redistribute plasma across the Sun. Chamberlain noted that these spicules could potentially contribute to the heating of the corona, which ties into the long-standing enigma known as the coronal heating problem. This mystery revolves around why the Sun's outer atmosphere, the corona, reaches temperatures in the millions of degrees, significantly hotter than the Sun's surface itself. This phenomenon seems to defy the laws of thermodynamics, as it suggests that temperatures increase as one moves away from the source of heat. Imagine sitting next to a campfire, only to find that the fire becomes hotter the further you step away from it. Scientists suspect that there is an underlying mechanism at play within the Sun that remains poorly understood. Chamberlain indicated that the CU Boulder team will investigate whether spicules play a role in this coronal heating conundrum. Another significant aim of the mission is to advance the technology behind this new spectrograph, paving the way for its application in future missions. Chamberlain expressed his desire to demonstrate the effectiveness of this technology so that the team can approach NASA and advocate for a larger, multi-year space mission. We're proving that this technology works and that the science is valuable through this quick and cost-effective method of data collection via a sounding rocket, Chamberlain explained. Additionally, this mission serves as an opportunity to train the next generation of scientists and aerospace engineers. Approximately 7 to 8 graduate and undergraduate students from CU Boulder have contributed to the development of the SNIFS instrument, with around 25 individuals at LASB involved in the project overall. These students are beginning to learn the intricacies of rocket science and engineering, Chamberlain noted. The next phase will involve them analyzing data and writing research papers. Once the rocket safely returns to Earth, the team will work diligently to upload the complete dataset and process it through various computer programs. They will begin analyzing the data, with some LASB team members tasked with creating 3D models of the Sun and its atmosphere to simulate the events captured during the mission. Hurd emphasized the importance of enhancing our understanding of the Sun, as it generates space weather and solar storms that can have significant impacts on Earth, including disruptions to communications, GPS outages, damage to satellites, and potential hazards for astronauts. We hope this small contribution will enhance our society's ability to model the Sun and predict when these hazardous storms are likely to occur, Hurd concluded. To catch the launch live at 1 p.m. on Friday, be sure to visit video.ibm.com/WSDF-WSMR. NASA's sounding rocket mission from New Mexico, a deep dive into the Sun's chromosphere. Think all rocket launches only happen from the famous coasts? Think again. NASA is about to send a high-flying scientific mission skyward from the deserts of New Mexico, defying the usual expectations. But here's where it gets more intriguing. The rocket in question isn't a gigantic, headline-grabbing colossus like SpaceX's Falcon 9, it's a far more compact craft, called a sounding rocket, about to embark on a journey with big scientific stakes. So, what's the real story behind these unassuming rockets, and why launch one from a place not typically on the space radar? If you're curious about NASA's next big step in understanding the Sun, and want to discover what professional space watchers don't always mention, read on. And this is the part most people miss, the importance of these. NASA launches sounding rocket to study Sun's chromosphere. Prepare to witness a groundbreaking mission that could unravel some of the Sun's deepest secrets. On July 18, NASA, in collaboration with an international team of solar physicists, will launch a sounding rocket from New Mexico to study the Sun's chromosphere, a region that has long eluded detailed observation. But here's where it gets controversial. Some scientists argue that the chromosphere holds the key to understanding why the Sun's outer atmosphere, the corona, is millions of degrees hotter than its surface. The chromosphere, a reddish layer nestled between the Sun's visible surface, the photosphere, and its scorching outer atmosphere, the corona, is a dynamic zone where solar flares, plasma jets, and intense energy flows originate. Temperatures in this region can fluctuate dramatically, ranging from about 6,000 degrees Celsius near the photosphere to over 1,000,000 degrees Celsius in the transition region just above it. The mission, expected to last less than 10 minutes, will carry a cutting-edge instrument called the Solar Eruption Integral Field Spectrograph, SNIFS. This innovative device is designed to capture high-resolution spectroscopic data from the chromosphere and the transition region in real time. According to Shovik Bose, a co-investigator of the mission, SNIFS is a first-of-its-kind solar instrument, and the first ultraviolet integral field spectrograph ever flown to study the Sun. SNIFS will provide a full 2D field of view, allowing us to extract a complete spectrum for every pixel in that field, effectively creating a 3D data set for each moment in time, Bose explained to the Indian Express. The instrument will focus on the hydrogen Lyman alpha line, the brightest line in the solar ultraviolet spectrum, which is crucial for diagnosing conditions in the upper chromosphere. And this is the part most people miss. By analyzing the data collected by SNIFS, scientists can calculate the temperatures, velocities, and densities of the solar plasma. This information is essential for understanding the complex dynamics of the chromosphere, a region that acts as a critical interface through which almost all the energy that heats the corona must pass. Bose emphasized. To solve the long-standing mystery of why the solar corona is so hot, we must first understand what is happening in the chromosphere. The chromosphere, though cooler than the corona, is much denser and rapidly loses energy. To remain active, it requires a constant supply of energy, and understanding this process is key to unraveling the broader puzzle of coronal heating. The technical setup of SNIFS includes a Gregorian-style reflecting telescope coupled with a spectrograph via a specialized mirror-led array. This array focuses the light from each spatial location in the image, allowing it to be spectrally dispersed without overlapping from neighboring areas. Solar physicists have faced numerous challenges in studying the chromosphere due to its composition of ionized plasma, which behaves unpredictably in the presence of magnetic fields. Additionally, the chromosphere does not conform to the assumptions of thermodynamic equilibrium, making it particularly difficult to model. However, a deeper understanding of the chromosphere is crucial for advancing our knowledge of the solar corona. The main agencies involved in this mission include NASA's Goddard Space Flight Center, the University of Colorado, and Queen's University Belfast, UK. As we await the launch, the scientific community is abuzz with anticipation, hoping that this mission will bring us closer to solving one of the most perplexing mysteries in solar physics. What do you think? Do you believe the chromosphere holds the key to understanding the Sun's corona? Share your thoughts in the comments below.